This video is going to introduce us to logarithms and how they work and how to evaluate logarithms, and then we'll end with graphing. So first of all, let's take a look at an example of what a logarithm looks like. It's going to feel strange at first because you've probably never dealt with this before, this math class, or seen this. And it's also a little strange to most people because it looks like a word, but this actually is a symbol right here. This log, just like when you see 2 plus 5, that's a symbol, but that doesn't look as weird to you because you're like, oh, it's just one little symbol. It's not log. So this is a symbol, just like a plus sign tells you to take 2 and take 5 and put them together and it makes 7, right? It tells you what to do. Well, log is the same way. Think of it like a symbol and it's telling us what to do. Now, this is read log base 2 of 8. So let's write that in our notes. It is read log, okay? And then whatever the number is that's here is written below, like a subscript right here. So log base 2 of 8. That's how this is read. So, whoops, need an E there. So it says log base 2. So this is saying 2 to what power is 8? That's what log represents. It means find the exponent. So this means find the exponent. So instead of a symbol like a plus sign, or like a multiplication symbol, or like a composition symbol like that, or 2 parentheses touching to mean multiplication, right? We have symbols. Well, log is a symbol that's saying find the exponent. So what exponent would need to go here that would make 8? I know it's kind of funny, but that's how it's written. I didn't make this stuff up. So 2 to what power is 8? So to figure that out, you would either, you have a calculator, or just do guess and check. 2 times 2, that would be 4. And then times another 2, that would be 8. So the answer to this would be 3. So the answer to a log is an exponent. So the answer to this would be 3. So I call this the rainbow. So if I had log base 2, 8, and I put that the answer is 3, if I make, or I'm sorry, not the rainbow, I call it the circle. So if I make it a circle, so if I go here to here to here, 2 to the 3rd power should equal this number here. So again, it might be weird to you if you've never seen this before, but that is what it's saying. Okay. So we'll come back to this. Let's skip over to number 9 while we're at it with that. So if it says simplify, or it could say evaluate the logarithm. Okay. It says problems like these will be on a no calculator test. Being that this semester our class is online, that doesn't apply to us. But let's go ahead and take a look at number 9. So this is saying log. So when you see the word log, it means find the exponent. That's what it's asking us. So it's saying 3 to what power gets you 81? So 3, what would the exponent have to be that will equal 81? So it's like a circle. Okay, so if you're not sure, you would write it on paper. So 3 times 3 is 9, and then another 3 times 3 is 9, and then that would be 81. So how many 3's do we need? 4. So the answer to number 9 would be 4. Okay, let's take a look at number 10. So this is saying 4 to what power is 4? So 4 to what power would get you 4? And the answer would be 1. You only need 1 4 to get 4. Okay, let's take a look at number 11. So when you see log, you tell yourself it means find the exponent. So 6 to what power is 1? So we know from chapter 6 that 6 to the 0 power, so anything to the 0 power is always 1. So that is why our answer is 0. So again, 6 to this power gets you that number that's written bigger. Okay, let's take a look at number 12. So this is saying 9 to what power is equal to 3? 9 to what power is 3? So far, we've learned about that we could have positive exponents. So if I had a 2, that makes it big. So 9 squared or 9 cubed, a positive exponent makes it larger than this. So a 0 exponent makes it always 1. So we're trying to think of how to get 3. Well, if we make the exponent negative, that just flips it. So it makes it a small value. So a negative exponent isn't working because it just flips it. So the 9 would become 1/9. So what are our other options? We learned about positive exponents, 0, negative. Well, we're going to need chapter 8. Chapter 8, we learned about fraction exponents. So if I raise 9 to the 1/2 power, so if the exponent was 1/2, you would get 3. So yes, you have to remember what you learned from chapter 8, and you have to remember, well, hey, if I square root 9, won't that get you 3? So the exponent for a radical, remember, it's inside out. The index is always the bottom, and then this exponent, which there isn't one, so I put a 1. So that's how we would know the answer to number 12 is 1/2. Okay, so we're going to go ahead and continue in a moment. Let's go ahead and finish up our notes that we skipped over up here. Okay. So we have a couple more up here to evaluate. Oh, we forgot to fill this out. So we did this one already, log base 2 of 8. It's asking you 2 to what power is 8. Okay, so that's the one we did there. And then it's asking us to evaluate log base 2 of -4. So this is saying here 2 to what exponent would be -4? Well, if we try 1, or I'm sorry, if we try 2, that would make 4, not -4. So a positive exponent wouldn't work. And if we put a negative exponent, that's just going to be 0.25, 1/4, right? So negative exponent doesn't work. And if we try a fraction exponent like 1/2, that doesn't give us a negative answer. So this is not possible. There is no way to raise a number to an exponent and get a negative value. Not possible. So we would write undefined. Just like when you can't divide by 0, they want us to also write undefined when it's a logarithm that can't be found. So there is no exponent that produces a negative output. That's why we're going to write that. Now, just like if we have x, if there's no number in front, we just know it's a 1 because it means multiply, and you can multiply 1 by anything and you get itself. We know that if we have a number and it doesn't have an exponent, we could put a 1 there. So just like we know that there's something there, just like a square root, right? The square root of 9. If there's no number there, you were taught that it's a 2. Well, with logarithms, if this number right here is not there, this little number here is not there, it's going to be a 10. So if we take a look at this example here, we have log of 100. So since that little number is not written there, it's implied that it's a 10. So whenever a logarithm doesn't have that base number, it's implied that it's a 10. So you would put a 10 there. And so this is saying 10 to what power is 100? So 10 to what power is 100? Well, 2, because 10 times 10 is 100. So the answer would be 2. So if there is no base number here, so if there's no base number like here, then it is a 10. Okay. So now here it says rewrite each logarithm in exponential form and each exponential in as a logarithm. Okay. So the answer is already there. So remember, log means find the exponent. Well, it already told us the exponent. So in other words, 2 to the 4th power, they gave us the answer, is 16. So that's what it wants us to do. It wants us to just write 2 to the 4th power is 16. So that's what the directions are saying. So it's saying go from log form to exponential form. Think of it this way. It's like saying if you have a fraction, writing it as a decimal. That's what we're doing right now. We're just going from the log form, or it's just like saying this. If I have the square root of 5, it's the same thing as 5 to the 1/2. It's a different form, a radical form versus an exponent form. So we're going from log form to exponent form. Okay, so log, you say to yourself, means find the exponent. Well, they already gave it to us. There's already a number over here. Down here, there was nothing on this side of the equal sign, so we had to find it. So this time they gave it to us, so we would just write 5 to the 0 power equals 1. Okay, this one here, I make the circle. It helps me. 3 to the 1st power gives us the number that's right here. This one here, 4 to the negative 2nd power equals 1 over 16. Okay, now example 5, it already has the exponent, so we need to write it with a log. So remember, the little number that goes here is the base, the number that has the exponent, so the 5. And remember, log means find the exponent, so the answer is going to be 3. So now 5 to the 3rd power equals 125. Okay, over here, log, the little number that goes here is the exponent, so it's a 3. And the number that it equals is the exponent, so -1. And then 3 to the negative 1st power equals 1/3. So we're just writing it with logarithms. Okay, over here, log, the little number here is the base, which is 8. A log always equals an exponent, so the exponent 2/3 goes here. So 8 to the 2/3 equals 4. Okay, over here, log, this has a radical, so I'm going to go ahead and write it as 4 to the 1/2 instead. So the base in this case, the one that has the exponent's 4. So I'm going to put log base 4. The answer to a logarithm is always the exponent. And then I make the circle. 4 to the 1/2 equals 2. Okay, so that's how you switch forms. Just like you would switch forms from a fraction to a decimal. There's steps. That's what we just did here. Okay, so I'm going to go ahead and pause this video and continue in the next video with number 13.